Yes, hi guys, welcome to our second presentation on GPON technology, and in this slide we are going to have a look at power splitting and link budget. You know, link budget, you must make sure that you have got enough power from the OLT to reach the ONT, otherwise no signal is going to be received by the CPE. As usual, my name is Motion Marufu, and for any communication with me, motionmarufu6@gmail.com. This is an important topic for telecommunication engineering. I hope you are going to enjoy it. A splitter is one of the passive devices found on the ODN, and we are saying what is the advantage of using a splitter or of splitting the power. We are saying it helps in sharing the cost and bandwidth of OLT among ONUs. On the OLT we find GPON interface card, and each GPON interface card is connected to various ONUs, meaning that one laser is connected to various ONUs. So we are saying this helps in sharing the costs and the bandwidth of the OLT. And the higher the splitting ratio, the more the sharing of the cost and bandwidth of the OLT. Another advantage is it reduces fiber mileage in the field, because we have got one fiber or one trunk fiber between the OLT and the splitter for P2 multi-point. It means that we are reducing the fiber mileage in the PON. So we are saying these are the two basic advantages of splitting the power. And please take note that the splitters can be cascaded, but this is not advisable. And we are saying in most extreme cases the feeder fiber forms an optical bus. This also is not recommended or is not used in the practical deployment of fiber. So we are saying from a management perspective, it is usually simpler to have a single splitter for each ODN, and this makes joining or the splicing of fiber easier, and it also minimizes connector and splice process. This is a very important point, and I know some networks that make use of only one splitter. There is no cascading of the splitters. This is the mostly commonly used power splitting strategy. We've got 1.4 power splitting, so this represents a splitter. And I said nowadays we are now moving towards a splitting ratio of 1:1.8, but you can still find in most networks a splitting ratio of 1:64. So we have got an OLT, a splitter, and some ONTs, and these splitters have been cascaded, and we are saying this is a point of power loss, this is a point of power loss, so it's going to reduce the reach of the PON. This is not even found on some networks. It is resembling the Cisma CD. So that's power splitting architectures. So we are saying this is one stage, a splitting, multi-stage, a splitting, or to be precise, two-stage splitting, and this is an optical bus. GPON outside plant, which means from the main distribution frame to the subscriber's premises or to the ONU. So we are saying from the exchange, that's where we find the OLT, and we are calling the next device, some call it the distribution hub, and in this slide it's being referred to as the fiber distribution terminal, FDT. So this is the feeder fiber from the central office, the distribution cable from the distribution hub to the network access point or to the network access terminal. It may require you to join or to splice the fiber. So this is the distribution fiber. We have cascaded some access points there. Then from the access point to various residential places, we call it the drop cable or the drop fiber. When you deploy your network, make sure you also cater for future developments, so that you'll be able to deploy your fiber early. So at the subscriber's place, that's where we find the ONU, also known as the ONT. So this simply shows how GPON is deployed from the exchange to the subscriber place. It's a splitter power loss. This must read a splitter power loss, and we are saying this is 1:2, 1:2, 1:2, and if you say 10 log 2, you get 3.5. So for a power of 2, we are saying there is a 3 dB there is a 3.5 dBm loss at every splitter. So for a 1 is to 32. 32 is 2 to the power 5. So you simply say 3.5 times 5 to give you 17.5 milli-decibels of loss. So this is how we are coming out with the power loss for these ratios. For 64 is 2 to the power 6. So if you say 6 times 3.5, you get a power loss of around 21 dBs. For this, if you say 3.5 times 5, you get a power loss of around 17.4. So this is how you calculate the power loss for each given splitting ratio. So you can see that the higher the splitting ratio, the more the loss. Hence, if you cascade some splitters, it means you are going to have more power loss at each splitter, meaning effective power delivered to or the reach of that particular PON is reduced. Hence, adoption of only one splitter on a PON. Guys, make sure you appreciate. More on splitting ratio and power loss. So we are saying a higher splitting ratio means cost of the PON OLT is better shared among various ONUs. However, this affects the power budget and the transmission loss. How do you come up with the loss? It's 10 log splitting ratio, 10 log 64. But it will give you a value of less than 20 dBs if you do it in such a way to be correct. So we are saying if you use a high splitting ratio, it means you now need a high power transmitter to make up for power loss at each splitter, high sensitivity receiver so that they are able to receive the weak signals, and also you will need the low loss optical components to avoid further loss in the fiber. So we are saying a high splitting ratio also means less power left for margin. You must appreciate what margin means. Normally when you are doing link budget, you leave a certain power loss for some unknown eventualities which may occur on your line, like aging. Equipment can age. So if you use a high splitting ratio, it means your margin be very small. So any degradation and variation will not be catered for if you use a high splitting ratio. So we are saying to a certain point, a high splitting ratio will create diminishing returns. The law of diminishing returns can find out this. So guys, take note of the disadvantages of a high splitting ratio or the advantage. Just as we budget our money, we are also supposed to budget our power, which is power from the OLT. And we are saying the distance spanned by PON depends on losses in the following network components: loss in the splitter, loss in the WDM coupler. Each fiber has got loss per kilometer. Also, where we include some connectors, there is loss at each connector, and also where fiber is joined, there is loss at each splice. So we must make sure that the number of splices is not much, and also don't unnecessarily use some connectors. This is beyond your control. There's nothing that you can do. Also, this is also beyond your control. So guys, take note of points of power loss on our GPON network and how they can be reduced. What we mean by this, the class B+, this is a laser. A laser is used as a transmitter in our ONUs and also in our OLT. Laser is a transmitter. So we are saying for B+, these are the transmit levels and these are the receive levels. So we have got the downstream budget as well as the upstream budget. So we have got the maximum transmit power and the minimum transmit power, and the receive level is in dBm, which means power gain with a reference to 1 milliwatt. So in the downstream direction 1490, in the upstream direction 1310 nanometers. This is another name for margin. It's a penalty, 0.5 dBs per kilometer. Then fiber loss per kilometer, 0.30 dB per kilometer. This is beyond your control. The minimum received power, it's from 0.80 dBm to minus 27.0 dBm. So this is the OLT and this is our ONU. So in the downstream direction direction, please take note that we use the minimum transmit power, which is 1.5, and we are saying 1.5 minus this is the lowest receive power, which includes or which represents our losses. So we are saying plus 1.5, which is this power, minus this is 0.5. So we can attribute this to this minus 27. So we are going to get a downstream budget 28 dBs. In the upstream direction, which is from the ONT to the OLT, we are going to use the minimum transmit power of the ONT, which is 0.5 dBs. Our losses due to our fiber is 28 dBs, and it's minus 28. So we are going to say this minus this is going to be plus minus this, so it's 28 dBs. So our downstream budget and upstream budget are the same, and this is for a class B plus laser. We are given the following data, and we want to calculate our physical reach of our PON. So we are saying our budget is 28 dBs, and we've got a 1:16 ways splitter loss of 38 dB, but theoretically it's 16.2. A connector and splicing loss of 3 dBs, margin or loss due to aging of 1 dB, and attenuation is 0.3 dBs per kilometer in the downstream direction and 0.42 dB per kilometer in the upstream direction. Please take note that the transmit power of the laser in the ONU is less than that of the laser in the OLT, hence 4 dBs per kilometer is compared to 0.3 dBs per kilometer. So we are saying the distance spanned by that PON is 28, which is our budget, minus the loss due to the splitter, minus connected splicing loss, minus loss due to aging. This is going to give us the total loss, and we are going to divide by the loss per kilometer in the upstream direction, which is 0.42. If you punch this in your calculator, you will see that your fiber is, or your PON is going to stretch for 24.8 dBs, 24.8 kilometers. So we are saying, how do you interpret this? We are saying for a 1:16 splitter, the maximum distance from the ONT or to the ONT is 24 kilometers. So you've calculated the range or the stretch in kilometers of your PON given this. It means if you use a higher splitting ratio, your stretch is going to be lower than 24 kilometers. Please take note. Normally, when we are talking of a transceiver, we are talking of a device that contains a transmitter and a receiver. So we are saying we are now going to consider a C plus laser, class C plus laser, and we are saying from the OLT, maximum transmit power 7 plus dBm, and the minimum transmit power is 3 plus. So we are looking at a power budget of 32 dBs in the downstream direction and 32 in the upstream direction. Our penalty 1 dB, 0.3 plus 0.3 dBs per kilometer, minimum receive power minus 30 dBm. So it ranges from there to there. So this is our ONT and this is our OLT. So we are saying normally when we are calculating the budget, we use the minimum transmit power and the minimum receive power. So we are going to say this 3 minus this 30 minus this margin, which is 1 dB, is 32 dBs. And if you compare with B plus is 28. So we have got more power when we are using a C plus. In the upstream direction, we are going to use the minimum transmit power and the minimum receive power, which is minus 32. And please take note that our budget is the same in both directions. All along, we have been discussing 1310 nanometers in the upstream direction, 4090 nanometers in the downstream direction. Now we are going to discuss a video transceiver, and this contains, or it transmits rather, at 18.5 dBs or milli-decibels. That's the transmit level, and the minimum receive level is fixed, is minus 1.4 dB, and there is no loss due to fiber per kilometer. So what's the power budget? It's simply the transmit power minus the receive power, and it's minus 23.4 dBs. Please take note that there is no transmission in the upstream direction because video is simply receive only. Why do you need to transmit when we have subscribed for you to receive some videos? So that's the power budget in the downstream. Optical power budget for video This is in the downstream direction, and we saw that it has got one transmit power and one receive power from the OLT to the ONT, and we are having a budget of 23.4 dB per kilometer, and we are using a 1:16 way splitter connector and splice loss of 3 dB, a margin of 1 dB due to aging, attenuation of the fiber 0.5 dB per kilometer. I said this is normally beyond your control. So what can be the maximum stretch for our PON? So we are saying our power budget, loss at the splitter, loss due to connector, and loss due to aging. To find the PON stretch, we are going to divide by the 0.25 dB per kilometer, so your PON can stretch for 22.4 kilometers. So please take note of the way how you can calculate the PON stretch given this kind of data. Maximum range per splitter configuration. Please take note of this important table. And we are saying for a split ratio of 1:64, which is this, we are saying the maximum reach, or the worst case reach, is 14 kilometers, which is this, and 10 kilometers would be the ideal one, or the best case. For a splitting ratio of 1:32, which is this, the splitting ratio represented by this is 1:32. It has got the best case and the worst case in terms of reachability, and we are using a B plus laser, and we are saying the best is 15 kilometers and the worst is 21 kilometers. For 1:16, please take note, the lower the split ratio, the more the reach, or the longer, or the longer the PON. So we are saying for 1:16, your worst case is 39 kilometers, which means your network cannot exceed 39 kilometers. And for a split ratio of 1:8, which is this 1:8, you can see you can connect a customer at 38 kilometers. The same applies to 1:2 and 1:4. So please take note that the higher the splitting ratio, 1/64 splitter or 1:64 splitter, that's we've got our OLT in the central office, or at the central office we've got our 1:64 splitter, the trunk fiber, the outgoing fibers. So we are saying this is a centralized splitter, and what are its advantages? Reduced draw cable length, and this is very good for where we have very high density developments, like in high density suburbs. And another advantage is there is a flexible use of splitters when they are centralized, and also we've got one location for testing of our fiber. So that's the advantage, or the advantages. These are the advantages or the characteristics of a centralized splitter like 1:64. GPON operation principle, we are going deeper. We looked at this in our first introductory presentation to GPON. So we are saying principle of GPON is called multiplexing, and we are saying we've got our OLT, which is our exchange, we've got our outdoor network, which is between the OLT and the ONT, and we are saying in the downstream direction we've got 1490 nanometers, and in the upstream direction 1310 nanometers. And we are saying all these are sent through one fiber. We are saying this is multiplexing and impliedly FDM. So we are saying voice and data are sent over a single fiber, and we are saying 2 or 3 wavelengths used. And in this diagram we are using 1310 in the upstream direction at this speed, 1490 in the downstream direction at this speed. So we are saying this is symmetrical, and this is video from the OLT. We are saying we are transmitting video at 1510 nanometers. So multiplexing enable us to send these signals, one at 1490, another at 1310, and another at 1515. So we call this multiplexing, the routing of signals from several sources through one transmission channel to their destination. And when they reach the destination, that's where we are going to implement demultiplexing. So multiplexing at the transmitter, demultiplexing at the receiver. Review questions and attempt these questions, guys. If you've got any challenges, you can use my email. This is very easy. What is a splitter in a GPON network or in GPON technology? A company uses a split ratio of 1:64. What does that mean? And what is the advantages and disadvantages of using a high split ratio on a GPON network? Calculate losses incurred on a 1:32 splitter, 1:64. What is the advantage and disadvantage of using a high split? This was repeated. And budget. Why is it important to have a link budget? And number 7, why is it important to include link margin in a link budget so that you deal with things like aging or other eventualities which may occur on a network that can result in loss. GPON operation in the downstream direction. The mode is called broadcasts. And broadcast simply means from 1 to all, not too many, but from 1 to all. And what are we saying? We are saying this is our OLT, and we are saying 1, 2, 3 represents these ONUs. So this is for ONU1, ONU2, ONU3 multiplexing. We are saying this is received by each ONT or ONU. Hence we are saying this mode of operation is called broadcast mode. Then this data has got some addressed, and we are saying this ONU can only process the data that is addressed to it. Hence it is managed process 1, which is this one, and it is this one which is received by this GTE. The same applies to this ONU. It receives number 2. ONU3 has received number 3. So we are saying each ONU receive all the data set from the OLT, but it is only able to process the data that is addressed to it. So we call this broadcast mode of operation of a GPON network. Optical access network architecture, we have got various types. Please take note that this applies to ADSL, and so we've got a DSLAM there. GPON, this FTTH stands for fiber to the curb, and this is the curb. This thing must be powered, and all these houses are connected to this multi-dwelling unit. Then we've got fiber to the building. This is our building, so we've got an optical network unit in the building. And please take note of the G.984 standard downstream and upstream speed. For fiber to the home from the OLT, please take note that at the subscribers premises we've got an ONT. Please take note that some service provider differentiate an ONU from an ONT, and this is their argument. They say multiple customers can be connected to an ONU while a single subscriber can be connected to an ONT, but generically these two means the same thing, but you never know these guys. So take note of the multi-dwelling unit. It is located away from the residential places, but these two, they are located at respective subscribers' premises. GPON reference model. You remember the reference model of an ADSL network. If you are not aware, you can look for one of our videos on ADSL technology. So we are saying this is the model of a GPON network. We are saying service is coming from there. So our OLT is connected to our service, and we are saying SNI stands for Service Network Interface, and their connection point is called the reference model. User network interface is called the T reference model. The ONT at the customer is connected to the customer's devices. So where they need to, we call it the UNI, user network interface, and it's called the T reference point. This is our splitter wavelength division multiplexing, and we are saying the reference model from the OLT to the ODN is called the SR. From the ONT to the ODN is called the RS. Please, I'm repeating it for the amphitheater time, and we are saying the ODN does not include the ONT and the OLT. So we have got a GPON interface card where our network is going to terminate. N stands for network equipment. So this is an OLT, this is an ONU or ONT. Please take note, they are used interchangeably. So that's the reference module for a GPON network. The abbreviations are instated in full. Network element or network equipment, SNI, service node interface, user network interface, optical distribution network, optical line, terminal, wavelength division, multiplexing. Please, this is for you. If you face any challenges, you can get in touch with me. The GPON reference model, SR and RS stands for, and state their significance. That's a question for you. This is our last slide insofar as our second presentation on GPON technology is concerned. Go through the questions, and if you face any challenges, you can get in touch with me on my Gmail. And logical reach, physical reach, maximum differential reach. Logical reach, we don't consider losses. Physical reach, consider losses. The difference between this and this gives differential reach. State mostly commonly used upstream and downstream speeds. And to test your understanding on engineering notation of stating values, required convert 1.24416 gigs per second to megs per second and kilobits per second respectively. Then what is the difference between the modes of transmission? Does TDMA mode and broadcast mode in GPON terminology? Then why do we have to do a link badges? Then what is the commonly used standard with insofar as stream and downstream are concerned? So guys, if you are learning something from our presentation, don't forget to like, comment, or to subscribe. Bye for now. Let's meet at video presentation on GPON technology. We've got 2 or more to go. Hope you're learning something.